In this video we are going to discuss Geek for Geeks weekly contest 159. Okay, so basically let's discuss our first problem. In Geekland, each item has a unique identifier made up of uppercase English letter A to Z. Here's how the identifiers work. A represent the number 1. Okay, here A represent the number 1 and B represent the 2 and C means 3 and up to Z it's 26 letters are given. A1, B2, C3 and up to Z there are 26, means A to Z we have total 26 letters. Okay, A to Z we have 26 letters. Okay, so basically as we go on adding and adding in letters by the right side of the alphabets. Okay, as we add letters at the right side of the alphabet, its value goes on increasing by 1. Okay, just a simple logic we are going to use. Means here after increasing a single A at right side, it will become 27, then at B it will give on 28, then AC it will become 29, then for AZ what it will become 26 plus 26, it is 52. Okay, then similarly till ZZ it will what become, it will become 702, such a large number. Okay, and it goes on increasing and increasing up to n times. Okay, so just what we have to do, we have been given an array. Okay, here you can see we have been given an array and we have to sort them on the basis of their values. Okay, we have been given an array here and we have to just sort them on the basis of their values. Basically the contest is too easy. Just the thing is the simple logic is to means apply the simple logic. Okay, just the simple thing is there and nothing else. Okay, so now let's discuss the approach. Basically what approach you are going to use. Okay, what approach you are going to use, basically you have to just do what, just do a simple thing. Okay, multiply the result, means take a result to 0 and run a for loop. Okay, initialize the result to 0 and run a for loop, and for each character update the result by multiplying the current result by 26 and then add the position of the character in the alphabet. Okay, just do a simple thing, a simple formula use, initialize result equals to 0 and use for char in s is basically our array. Okay, and result equals to result into 26. 26 is the length of the array, means from A to Z the total number of alphabets. Okay, and what we will add the ordinary of char. Okay, minus ordinary of minus ordinary of A plus 1. Okay, so basically how it works, okay, A equals to what, 0 into, as R is 0, so 0 into 26 for, wait a minute, for A basically R equals to 0 into 26 plus what, plus ordinary of char minus ordinary of A. So basically the value of char is basically ordinary, our char is basically what, A, so it will be 1 minus 1. Okay, plus 1, so basically plus 1, so basically our R will be equals to 1. Similarly for AA, our R will be equals to 1 into 26, as we have completed the one a, so it will be 1 into 26 plus what, 1 minus 1 into 1, so it will be 27. Okay, so basically this is the logic, and let's try to see the code. Okay, so basically it's the code. Okay, let's try to do some implementations. Okay, so basically I have created an recursion. Okay, I have used a recursion string to number, string to number. Okay, and result equals to 0 for char in s. Of char in s means the character in s, the result will be equals to result in result into 26 plus ordinary of I minus ordinary of a plus 1. Basically the ordinary gives the value of a, means value, it gives us the value. Then we will return sorted items, key string to number, string to number. Okay, yes, let's try to compile it. Yeah, it's giving some runtime error. I is not defined. Yeah, I is not defined. I forgot to change the I. Yes, it's char basically. Yes, now I think it will run properly. Return result. Basically I, for you only I changed the variables and now it's giving some problem. I think it will run now basically. Yeah, it runs successfully. Yes, it has been submitted. Okay, now let's jump on to the next problem, bridge on bits. So basically I have solved I was able to solve all the three problems in the given time limit. So now let's read down. Basically we have, in this problem statement, what we have been given, we have been given an array of length n. Okay, we have been given an array of, so basically we have been given an array of length n, and our task is to construct a bridge. Okay, our task is to construct a bridge of what, a bridge of all the numbers in the array. Okay, and it's said to be complete, it's said to be complete if for any ith bit all the number in the array have their ith bit set. In one operation you can flip any bit of a number in the array. Okay, just you can flip any number of bit in the array, then in one operation you can flip any bit of the number if the bit is 0. Okay, so make it 1 or vice versa. Your task is to just return the minimum number of operations required to construct a bridge. Okay, simple, pretty simple question. Just we have been given an array of numbers. Basically we have to convert it into, from integer to binary. Okay, basically for 1 is 0 1 0 0 1, for 2 is 0 1 0, for 3 is 0 1 1, for 4 is 1 double 0, and for 5 is 1 0 1. Okay, good. So basically what we have to do, just create a bridge of numbers. Okay, wait a minute, let's make it more pretty. Yes, so basically here I have again rewrite the number in their original form. Yes, so basically we have to create a bridge, okay, in these numbers. So first we have to count the bits, okay. So basically first I am taking the first row, means first column. So basically it's 1 0 1 0 1. So we have to count the number of ones. Number of ones are what? 3. Okay, so now what we will take second row. Okay, just we will take second row, this. So it's basically what? 0 1 1 0 0 0 1 1 0 0. So basically our number of ones is 2. Okay, pretty simple. Yes, so now our last row is 0 0 0 1 1. Okay, 0 0 0 1 1. So basically it's here also number of ones is what? 2. Okay, so what we have to do, we have to create a bridge of numbers, means we have to perform some operations to create a bridge. Okay, means this all numbers must be 1. Okay, so basically now it's 1 1 1 1 1. Okay, so this is a bridge now. Okay, so just we have to create a bridge by cancelling out the numbers. We have to perform the minimum number of operations to create a bridge. Basically here the number of ones are 2, so we have to perform 3 operations, means 1 1 1, 3 operations in this. Here also 3 operations, here also 3 operations. But here in this we have to perform only 2 operations, because the number of ones are 3 and total integers are what? Total are 5 integers in this row. Okay, and number of ones are 3, so basically we have to perform 2 operations. So this is the basic or simple logic. Basically now let's take some another example. 623. Okay, in this it is for 6 it's 110, for 2 it's 010, and for 3 is 011. So basically there is already a bridge in this. So number of operations minus number of ones, basically the number of integers minus number of ones equals to 0, so 0 operations. Okay, so this is the basic logic in this question. So now let's try to understand this by code. It will be more simpler for you. Yes, yes, now let's see. Okay, so basically the code, first of all we have taken a length of an array as e is equals to length equals, yes, okay, n minus let's count. Yeah, now it's okay. So I have taken e as the length of an array. Okay, and maximum bits equals to maximum of arr dot bit length. So it basically determines the maximum number of bits. So basically it determines the maximum number of bits needed to represent largest number in array. Okay, so means just it determines the bit length. For example, in what in 2 it's 0 1 0, the number of bits are 3. Okay, so in means 2 in there is 10 only 2 bits. For 3 it's 11, but for 4 it's 100 3 bits. How can we compare 2 bits? For example, 2 it's 10, for 3 it's 11, but for 4 it's 100. So basically it's have 3 bits, it's 2, and it's also 2. Okay, how can we compare 3 with 2? So that's why we have to find the maximum bits. Okay, so maximum bits are 3 in this. So that's the logic between behind this. Yes, so now we will do the bit count. Okay, bit count equals to means initialize 0 to a list and multiplied it max bits, means it initialize the list bit counts to keep the track of count of ones in each bits, means position up to max bits it keeps a count of ones. Okay, then we will run a loop through each number in array. Okay, then for each num in array will iterate to each bit position up to maximum bits. Then we will use bitwise operation. Okay, bitwise operation for num and one and j to check if the j bit is set 1 in the number num. Okay, if the jth bit is set 1 it will increment, it will just increment. Okay, here, yes, so the jth bit will just increment by bit counts of j. Then what, then we will count the maximum bits. Okay, maximum bit counts means maximum of bit counts. Basically uh, for this example you can see, yes, so basically for this example it's what 1 0 1 0 1. Okay, then 0 1, then what, it's 0 1 1 0 0 0 1 1 0 0, and then triple 0 1 1. Okay, so we will find the maximum bits count, it's 3, it's 2, and it's 2, means number of ones. So the maximum of it is 3, so just return it to 3 and then we will subtract from e. Okay, so basically now we will subtract the maximum count means number of ones from n. Okay, from n we will subtract the maximum count. Basically n equals to length of error minus max count means number of ones, so basically it will return 2. Okay, let's understand the logic between this. It's 1 1 0 1 1. Okay, the number of ones are 4 and total numbers are in this 5. So 5 minus 4 equals to what, 1. Basically we have to perform one operations to replace this 0. Okay, this is the basic logic between this. Now let's try to compile and run. Yeah, it's giving correct output. Now let's try to submit it. Yeah, it's giving the successfully executed. So now let's jump on to the next problem statement. GSB interview. Yes, so basically this question, yes, this question is bit pretty simple, but the just one thing is that the time complexity here, it's just affect the hardness of the question and nothing else. Okay, so now let's try to understand the problem statement. There are n aspiring geeks arriving at different times. Okay, for GSB Geek Selection Board. So basically, what we have to do in this, the geeks arrival for each time is given by arrival of I. Okay, then the GSB can organize up to M interview. Okay, yeah, wait a minute. Yes. Hmm. I think I have jumped onto the wrong question. Coding problems. Yes. Huh. Okay. So basically, what the problem statement states that we have been given the length of an array. Okay, we have been just given the length of an array as n equals to length of an array. Okay, then basically what m is the number of interview session up to m number of interviews. Okay, m is the basically number of interviews. Then we have to accommodate up to k gigs. Up to k people can go in interview. Number of people go in interview. Go in interview. Okay, so these basic points are given. And arrival is basically the time at which the people's the geeks arrives. Array of time, array of arrival times. Okay, so these four constants we have been given, and we have to solve the problem statement. Basically, let's try to understand with the help of an example. Okay, the first session of interview will start on t equals to 4. Okay, where first and fifth gigs interviews will be taken. Yes, for example, we have been given an array 4 3 6 9 3. Yes, so this is the arrival times. Okay, we can conduct at least 2 interviews, and in each interview 3 gigs means 3 people can be accommodated. Means at least 3 people, at most 3 people can come to the interview. Okay, so basically we have been have an array of length 5. So in one interview 3 people can go, and other interview 2 people only can go. Okay, so basically at t equals to 4 means we will start from first position. Okay, first position is t equals to 4. at मतलब 4 बजे. Okay, we can see that the other geeks came at, someone came at 3 o'clock, someone at 6 o'clock, someone at 9 o'clock and someone at 3 o'clock. ओके हम देख सकते हैं कि कुछ लोग 4 बजे आए, एक बंदा 4 बजे आया है, दो बंदे 3 बजे आए, एक बंदा 6 बजे आया है और एक बंदा 9 बजे. ओके, सो दिस इज द टाइमिंग्स. सो पहले बंदे हम लोग स्टार्टिंग से स्टार्ट करेंगे, मीन्स वी विल स्टार्ट फ्रॉम द फर्स्ट इंडेक्स. तो पहला बंदा 4 बजे आया, तो फर्स्ट इंटरव्यू 4 बजे स्टार्ट हुआ. फर्स्ट इंटरव्यू कब स्टार्ट हुआ? 4 बजे एट 4 o'clock. ओके, सो बेसिकली 4 बजे के बाद आसपास कौन कितने बंदे हैं? 3 o'clock वाले, मीन्स 3 o'clock. सो बेसिकली एक इंटरव्यू में 3 बंदे अलाउड है ना? एक इंटरव्यू में 3 बंदे अलाउड है. मीन्स इंटरव्यू स्टार्टेड एट 4 o'clock. इंटरव्यू started at 4. So we have 2 people sitting from 3 o'clock. Sitting from 3 o'clock. So basically हम 3 लोगों का इंटरव्यू लेंगे. We will take interview of 3 people, 4, 3 and 3. So there is a loss of these 2 people. Okay, they have to wait 1 hour more. Interview started at 4 o'clock, but these people came from 3 o'clock, so they have to wait 1 hour more. So their time has been wasted. So it will be number of hours they sat, okay, in the cabin, in the waiting area. You can say they sit in the waiting area for 1 hour till 4 o'clock. Then the second interview started. Okay, second interview started at what? 9 o'clock. Okay, second interview started at 9 o'clock. Is that clear? So one boy is sitting at from 6 o'clock. So basically what, this boy has to wait for 3 hours. So maximum number of hours is basically 0, 1, 3, 0, 1. So what is the maximum number of hours? Is 3. So just we have to print the maximum number of hours. Okay, so this is the basic logic. Let's try to understand by another example. It will be more easier for you to understand. Yes, for example, the arrival times are 5, 2, 4, 6. Yes, these are the arrival times. Someone came at 5 o'clock, someone at 2 o'clock, someone at 4 o'clock and someone at 6 o'clock. Okay, so basically what we have been given, K as what number of geeks can accommodate and M as number of interview session. So basically K people are means 5 people can attend a single interview. Okay, we can attend, we can organize only one interview, and in that interview 5 people can come, and we have total of 4 people. So basically yes, in one interview this all peoples can come. So the interview will start at 6 o'clock. At 6 o'clock it will start. Okay, it started at 6 o'clock. So basically people at 5, they sat for 1 hour. People at 2 o'clock, they sat for 4 hours. Okay, sat for 1 hour. People came at 2 o'clock, they sat for 4 hours. Then people at 4 o'clock they sat for 2 hours, and 6 o'clock came on right time, so 0 hours. So the maximum time wasted is 4. Okay, 1, 4, 2, 0. Maximum is 4. So our answer is just 4. Okay. So this is the basic logic and nothing else. And our constraints are the n should be less than or equal to 10 to the power 5, and arrival of 5 is must be 10 to the power 9. Okay. Now let's try to understand with the help of a code. Okay. Yes. So basically first of all we have sorted. What we have done, sorted. Why we have sorted the array? Sorting means arrival times, for example it's 9 o'clock, 7 o'clock, 2 o'clock, 10 o'clock. So after sorting it will be 2, 7, 9, 10. Okay, so we can set that the last arrival time, at the last arrival time the interview will start. Okay, at the last arrival time the interview will start. Okay, so basically, yes. So we will use binary search here. Means you can use an recursion of can schedule within time. So we have used current time equals to 0, then session used equals to 0, and geek index equals to 0. Okay. Then we have run a while loop. Until it will run until it's less than n. Means it will run till the length of the array arrival time. Okay. If session used is equal to m, means if the number of sessions used are equal to m, means the sessions are completed, we will return just false. And after each session we will increment. Okay, increment by 1. Okay, then what? Then we will just store the current time in arrival. Okay, and increment the geek index. Means the geek index means the total people are coming from interview. So we will again run a while loop. While wait a minute. Yes, while geek index is less than n and count is less than k, and arrival of geek index is less than equal to current time plus t, the counter will increase by 1 and we will return 2. Basically here means initialize low to 0 and high to difference between the latest and the earliest arrival times. Okay, and the mid we have run a iteration. Okay, and our mid is what? Mid is low plus high by 2, means it will check all the geeks and we schedule such that no geek wait longer than 3 time units. Okay, using the greedy scheduling we will start first at first session at time. Okay, then there will be the waiting time. Basically let's try to understand with the help of an example. It will be more simple for you. Let's try to dry run the code. Okay, after dry run it will be more simple for you to understand. Yes, for example n equals to 5, k equals to 3, m equals to 2, and array is 4, 3, 6, 9, 3 only. Yes. So first of all we sort it. First what? Sort. Up 3, 3, 4, 6, 9. Okay, this we have done. Then we will use the binary search initialization. Binary search. Okay, we will set load to 0. Okay, and high to difference between latest and earliest arrival times. I equals to what? Latest and oldest arrival time means 9 minus 3. Okay, this one 9 minus 3 equals to 6. Okay, then what? Then we will do binary search execution. Okay, so basically at iteration 1 are made at iteration 1 are made is basically 0 plus 6 by 2, which is equals to 3. Okay, so now we will check for all geeks can be scheduled such that no geeks wait longer than 3 time units. So using greedy scheduling we will start first session at 3, then schedule geeks will be 3, 3, 4. Okay, so in first session this will be 1. So geek 1 arrival at 3, waiting time equals to 1. Okay, the second Greek arrivals again at 3, waiting time equals to 1, and then 4, its waiting time is 0. So basically for here our waiting time equals to what? 1. Okay, so basically what we have to observe the maximum waiting time. Okay, the maximum waiting time we have to observe here and just return. Okay, so basically uh, wait a minute, let's suppose for example let's make it easier, let's make it easier for you. Yes, so basically for this for 3 the waiting time equals to 0. Again for 3 the waiting time is equals to 0. Okay, then for the waiting time equals to 1, and then for 6 the waiting time equals to 3, and then for 9 the waiting time equals to 6. Okay, so these are the waiting time, and the maximum time observed is 6. Since 6 is greater than 3, then update high. As 6 is greater than 3, we'll update high. High equals to what? 3 minus 1 equals to 2. So basically we have sorted, we have used binary search, then updated high. Then in iteration 1, this we have done. Okay, so then at iteration 2, then at iteration 2, what we are going to do? Our mid is going to equal to be 0 plus 2, as our high is 2, so it will be 0 plus 2 by 2, which is 1. Okay, which is 1. So we will check for the gigs which can be scheduled longer than 1 unit time. So it is So basically our gig schedule will be 334. Okay, longer since the waiting time is our mid is 1. Okay, so basically for 3 our waiting time is 2, then for again 3 our waiting time is again 2, then 4 our waiting time is 0. Okay, then for 6 our waiting time is 3. Okay, so we cannot be scheduled in first session due to limit of k. Okay, then what schedule remaining in geeks in second session starting at time 6. So basically it yes, for second session it will be 0, 9 waiting time equals to 3. Yes, so maximum waiting time observed is 3, maximum is 3. Okay, so let's update high. High equals to 1 minus 1 equals to 0. Okay, so we have updated our high. Then iteration 3. Okay, so for iteration t, let's update mid. Mid equals to 0 plus 0 by 2, which is equals to 0. Okay, we will start the first session at time equals to 0. Then schedule gigs will be 3, 3, 4, 6, 9. These are our scheduled gigs. We'll calculate the waiting time. Okay, so basically for 3 our waiting time 0, again 3 our waiting time equals to 0. Yes, then for 4 our waiting time equals to 0, then for 6 our waiting time equals to what, 0, and then for 9 our waiting time is equals to 3. Okay, so maximum waiting time is what, 3. So update our result to 3. Okay, so this is our final answer. So by this we have done the algorithm for it. One time read it, you will understand. I've explained it better, and if you didn't understand, you can ask me in the comment section. You must be seeing the official Geek for Geeks solution. I don't know you will see my video or not, so please like, share and comment. And this is my code. Okay, if you have any of the doubt, you can ask me in the comment section. Okay, so thank you very much.